Alright everyone, today I'm just going to do 4 questions related to projectile motion and use those formulas we derived the last lesson to help you to understand how to solve questions like those projectile motion questions. Alright, so here's the first one, question 2 from exercise 10a. A particle is projected from the horizontal ground with a speed, okay, so that is the initial speed. Alright, so with the speed of 40 meters per second at an angle, okay, so that's the angle of inclination or the projection angle, which is 30 degrees to the horizontal. Now, starting with x double dot equal to 0, y double dot equals minus 10, so they're using g as is like 10. Then you're going to show that x dot, which is the horizontal velocity, and y dot, vertical velocity, is given by these two answers there. All right, so we're going to start with our equations. Right, so for question A, the first step what you do is obviously you're starting from, now you can draw a diagram if you want to, but you don't have to. To draw a diagram, it's just going to be the first case parabola, okay, and a projectile motion question. The initial speed, u is equal to 40 meter per second, with the angle here, theta, is equal to 30 degrees. Right, so that's a little diagram. All right, now from here, what we can do is we can start to integrate. Okay, so we know x double dot is equal to 0. So x double dot is equal to 0. Then x is equal to, well, if we integrate that, x double dot dt, we're going to get u cos theta. I hope you still remember this because u cos theta is just the first constant. Right, from here, what we can do is, what's u? Well, u is 40 meter per second, cos 30 degrees, and then we can further simplify this. Cos 30 degrees is square root of 3 over 2. All right, so the final answer will be 20 square root of 3. All right, that's what x equals to. So that's how we proved. Okay, all right. Oh, by the way, I made a mistake. That's x dot, not x. Because once we integrate that, it's x dot, which is the velocity. All right, so then we can move on to the y double dot. Y double dot is negative g, but this time it's negative 10. And then if we integrate that, it will be y dot is integrate negative 10 dt. That gives you minus 10 t plus c. And this time, the c is u sine theta, the initial vertical velocity, okay, u sine theta. All right, so that gives you minus 10t plus u is 40 sine 30 degrees. And that becomes minus 10t plus 40 times by half. Sine 30 is equal to half. All right, so that gives you minus 10t plus 20, which is the correct answer. So we just finished and proved the first question here, which is pretty easy. All right, so the second question asks us to find x and y in terms of t, which means they ask us to further integrate and find the other two equations in terms of the displacement this time. Okay, so let's do that. Let's just look at the initial condition. It's starting from the horizontal ground. That's all we need. Okay, all right. Okay, so x is equal to, when we integrate 20 square root of 3 dt, and then x is equal to 20 square root of 3 t. Alright, so that would be the first answer, the displacement function here. Oh, you can call that horizontal displacement function. Now, with the vertical displacement function, y is equal to integrate negative 10t plus 20, okay, dt. Oh, I'm pretty sure I need to plus. Okay, now, yes, I didn't really mention anything about plus c here. The reason for that is you do need to plus c, but because the starting point is the origin, and that means there is no horizontal shift. So that means the starting point is always at 0, 0. So we don't have to worry about plus c for the horizontal displacement. Okay, so that's the reason I sort of like, avoid to talk about that, but I should mention that before. Right, now back to this. So y is equal to minus 5t squared plus 20t plus c. Again, it's starting from the ground, so therefore c is equal to 0, and then we don't have to worry about a c anymore. that just c is equal to 0, and that's all we need to do. All right, so y is equal to minus 5t squared plus 20t. Okay, so that's the vertical component of the displacement. Okay, all right, so we've got a horizontal and vertical now, and let's have a look at what's the next question. So the next question asks us to find when the particle returns to ground. So this is what we have talked about before. All right, when means the time of flight, and then the horizontal distance means the range, and the last one is the greatest height or the maximum height. All right, so the question asks us to find all these three information there, all right, which is the one we just did last lesson. And I remember I told everyone this is what you need to remember to do, and we have all the equation we need, and we should be able to solve those questions there. All right, so let's start to do that. All right, the first question asks us to find when the particle reached the ground again, okay? All right, so we're going to start with y equals to minus 5t squared plus 20t, and we're going to let y equals to 0. Reach the ground means the starting point. The vertical distance is, there is no change in vertical distance, so therefore it is going to be 0, okay? All right. Next, minus 5t squared plus 20t is equal to 0. So if you take negative 5t outside, so t minus 4 is equal to 0. T equals to 0, t equals to 4. All right, so when t equals to 0, well, obviously that is the starting point. And then when t equals to 4, then you should know that's the 4 seconds later, the particle reached the ground again. Okay, so C, the first part, finished. And that is our answer there. Okay, now D, the second part. What is the range, or the question says the horizontal distance traveled by the particle? All right, the horizontal distance is x equals to 20 square root of 3t. Now what we need to do is substitute how long it takes for the particle to reach the ground. Well, t equals to 4. So if we substitute that number inside, we're going to get x equals to 20 square root of 3 times by 4, and that becomes 80 square root of 3. Okay, that's what x equals to. And it's meters. So that becomes the horizontal distance, how far the particle has traveled. Okay, the horizontal distance traveled by the particle. The last one is find the greatest height. All right, now with this question, now I have mentioned that before. Just with this question you can do it. With other question you can't. Just with this question, it's really special. It is a symmetrical diagram. Okay, so at this point t is equal to 0. At that point t is equal to 4. Just because that's a symmetrical diagram, so that's why right in the middle, at that point, time is equal to 2. So you don't really need to use the first derivative of y, which is y dot, and let the y dot equal to 0 to find the time. Because it's a symmetrical diagram, so you can assume that, maximum height happens when t equals to 2. All right? So once we know that information, we can substitute t equals to 2 into the y equation, which is that equation negative 5t squared plus 20. So therefore y is equal to negative 5 times by t squared plus 20 times by 2. All right, so 2 to the power of 2 is 4. 4 times by that is 20 plus 40, and the answer will be 20 meters. That's how the greatest height, okay? That's how far, or, what is the furthest in the vertical distance that particle has traveled, all right, which is 20 meters. Okay, so this is a standard question, really simple. Basically, you just integrate twice to get the x and the y equations, and you're going to find the time of flight, find the range, find the maximum height. Standard question. Just practice those ones like later at home as well. All right, so now let's move on to the next one. Okay, so the next question. Let's read the question here first. A particle is projected from the origin. All right, very, very important, from the origin. Its horizontal and vertical component of displacement after t seconds. Okay, so they give you the horizontal and vertical component all right, which is really easy. We don't have to integrate it anymore, but maybe we need to differentiate, so the other way around. Okay, that's maybe what we need to do. Find the initial value of x dot y dot. Yeah, see, that asks us to find the initial velocity in both components, all right? So A, x equals to 40t. Then x dot is equal to 40, because we'll just differentiate. So that's really easy. Next, y equals negative 5t squared plus 25t. Then y dot is minus 10t plus 25. Okay, really easy. But we still haven't finished the question, all right? The reason for that is you have to pay attention to the key words here. Initial values. All right, initial values means when time equals to 0. Very, very important. Time equals to 0. We're going to find out the speed or, initial velocity when time equals to 0, okay? So x dot is equal to 40, still equal to 40, because when t equals to 0, this is independent of t. As you can see, there's nothing there, all right, just 40 by itself. So it's independent of t, so don't worry about that. X dot is 40. All right, now next is y dot. When t equals to 0, y dot is negative 10 times by 0 plus 25. And that gives you y dot equals to 25. Okay. All right, so that's the initial values of x dot, y dot. All right, now we can move on to question B. Hence, show that the initial velocity is equal to that number there, and you're going to find approximately 32 degrees. So how do we find the initial velocity? Well, there's a couple of ways you can do it. You can use the vector to do that. You can use a triangle to do it. So many ways you can do it, all right? And then you can find the angles quite easily. You can use Pythagoras. All right, so how do we do that? Well, draw a diagram. If you think about vector forms, right, horizontally it goes that direction is 40, and then vertically, or let's say vertically, is 25. All right, so the particle is going this way. Now, what we can do is we can sort of shift this vertical component this way. All right, so we have a diagram like this. All right, so let me just remove all of this. So as you can see now, vertically that becomes 25. It's like a vector, so you have a head to tail, okay? And then, so the resultant velocity goes that direction there. So what you need to do is, obviously, we just have to find this answer there. How do we find it? Well, Pythagoras. All right, so the initial velocity will be equals to 40 squared plus 25 squared, and you square root that. Okay, so the answer should be, let me just use a calculator to do the calculation. Square root of 2,225. All right, how do we simplify that? Try 25. Oh, great. So that becomes 5 square root of 89. All right, so that's the initial velocity. By combining these two resulting velocity joined together, so you get the initial velocity. Now, angle. How do we know the angle? So the next thing we need to know is about angle. The angle is the angle here. All right. How do we find this angle here? Well, using trigonometry, SOHCAHTOA, we can easily find this angle. Tangent theta is 25 over 40. So therefore, theta is tangent inverse 25 over 40. And that actually gives you roughly 25 over 40. Okay, so roughly 32 degrees. And that's the angle. All right. Oh, okay, so that's the answer. Great. Because the question asks us to prove this is the answer that I just did. Okay, so a very simple question, just all right. But this time, a special way to find the initial velocity using the vector form, and you can use Pythagoras as well to work out the final answer there. All right, very easy. By shifting the components around, you should be able to do that quite easily. Okay, let's move on. All right, question 8. A particle is projected from a point with an initial speed v, okay, at the angle theta. So we don't know v, we don't know theta. After 2 seconds, its horizontal and vertical displacement from O are both 30. Okay, so that's a very important information there. Show that V cos theta equals to 15, and you're going to show that V sine theta equals to 25. All right, so what do we do is here? How do we do it? What do we do? Well, I guess what we need to do is we need to generate that, 6 equations, right? So let's start with this. We need to have those 6 equations. X double dot is equal to 0. X is equal to V, because they give us V this time, so we'll just use V, cos theta. X is equal to VT cos theta. Y double dot is minus G. Y dot is minus GT plus V sine theta. And Y is negative half GT square plus VT sine theta. Okay, alright. Now we have this. So what? What do we do? We need to use this information. After 2 seconds, horizontal vertical displacement are both equal to 30. We have the horizontal and vertical displacement. How about we substitute t equals to 2, x equals to 30, y equals to 30. And maybe we can prove what we need to prove later, okay? So let's do that. All right, substitute t equals to 2 for the first one. We're getting 30 equals to 2v cos theta. So v cos theta equals to 15. Pretty sure that is what we need to prove. Yes, that's correct. So we are on the right track, okay? So we can do the substitution for the next one, all right? So we should be able to get the right answer this time. All right, so let's substitute this number in. The problem here is very strange because this question didn't tell us what's the value of G. All right, it's 9.8, but the problem with that is I have a feeling if I substitute 9.8 as a G, we're not going to get 25, that exact number. So how about we let G equals to 10? All right, this is never going to be like this in an exam. In the real HSC exam, they will tell you what is G if they wanted to write 10. Otherwise, it is always assumed to be 9.8. Okay, so let's times by 10 times by t squared, so 2 squared plus 2v sine theta. All right, let's see if my G is correct. So it's 30 minus 5 times by 4 plus 2v sine theta. Okay, all right, what do we do now? Yeah, I'm pretty sure that's all right. Yep, okay, so let's move on. That's 20, that's 30, so combined that's equal to 50. That's 2v sine theta, so now it becomes 25, which is equal to v sine theta, and that's what we need to prove, okay? So v sine theta equals to 25. Done. We just proved that. Okay. Again, they didn't tell you what's the value of G. They just assumed that you know G is equal to 10, which is not a really good question there. Okay. Usually the question would tell you. But, well, anyway. Hence, show that V is equal to this amount, all right, and theta equals to that. All right, so that becomes the previous question. Just find the initial velocity and the angle. So how do we find the initial velocity and angle? We have these two equations. From these two equations, we can form a simultaneous equation. So V sine theta equals to 25. Equation 1, equation 2. A couple of ways you can do that. What we can do is we can use equation 2 divided by equation 1. So if we divide that, we'll get tangent theta is equal to 25 over 15. And 25 over 15, after you simplify it, it should be 5 over 3. I don't know why I'm using a calculator to do that, but theta is equal to arc 10 5 over 3. Or you can just write tangent inverse 5 over 3. Now the reason I write arc 10 5 over 3 is because that's what the question gives us arc 10. Another form to write an inverse trig. Right, so we're on the right track. Okay, that's how we find the theta. Now we just need to find V. How do we find V? Well, you can substitute the theta inside to find V, but it's not ideal, okay? The proper way to do that is 1 square plus 2 square. So equation 1 square and equation 2 square. And you plus them together. you're going to get v squared cos squared theta equals to 15 squared. And then v squared sine squared theta equals to 25 squared. And then if you plus them together, you will get v squared cos squared theta plus v squared sine squared theta equals to 15 squared plus 25 squared. And that gives you v squared bracket cos squared theta plus sine squared theta, which is equal to 15 squared plus 25 squared, is 850. That's it. Cos squared theta plus sine squared theta, have you remembered, that is equal to 1. So therefore, v squared is equal to 850, and you should be able to square root that number there. 850, okay, let's check the answer there. It's a 5 square root of 34. Sorry, 850 divided by 25 is 34. Good. That is our right answer there. 5 square root of 34. Okay, all right, so that's how we do this question here. Still pretty easy, not a harder question. All right, let's move on. A projectile was fired from, that's question 11, level ground and has just cleared a wall that is 10 meters high and 20 meters from the point of projection. If the angle of projection is 36 degrees, what is the initial speed? Okay, what is the initial speed? So we have 2, 1, and 2, and 3 pieces of information here. We know the angle of projection is equal to 36, right? So let's just draw a diagram. Here is the projectile motion. I know the angle is 36 degrees. I have no idea about the initial velocity, but the question says it just cleared the wall that is 10 meters high and 20 meters from the projection. All right, let's just say that's 20 meters from the projection. Here is the big wall, and then it is 10 meters high. And it says just clear the wall. And the question asks you, what is the initial speed of the projection? All right, so how do we do that? Pretty easy. As long as you remember this point, at this point, you will have the x-coordinate equals to 20 and the y-coordinate equals to 10 at that point. So I guess what we need to have is, again, 6 equations. We need that 6 equations so we can generate everything we need. Yeah, and hopefully we can do some substitution to work out the final answer there. Okay, let's start. All right, so we'll start again. X double dot is equal to 0. X dot is v cos theta. We know theta is 36 degrees. I'm just going to write 36 straight away. X is equal to vt cos 36 degrees. Y double dot is minus g. Looks like we need to assume that minus g is still equal to 10. Okay. G equals to 10. Y dot is minus gt plus v sine 636. And y is minus 5t squared plus vt sine 36 degrees. Right, so once we have this, now back to the question. How do we do it? We don't know the time. We have no idea how long it takes for the particle to reach that time. All right, so that's something we don't know. But we sort of know what is x and y, right? So what we can do is, if we substitute x equals to 10 and making t is the subject here, and once we finish that, we substitute into the second equation, and somehow maybe that will help us to simplify or evaluate the value of v. And then once we know the v, we should be able to work out the answer, right? Okay, let's see if that works. So x is equal to 10, vt cos 36. So t is equal to 10 over v cos 36. Wow. Okay, now we need to substitute everything. So sub t into y. And we know what y equals to. Y is, I think I made a mistake. What is the value of x? X is 20, not 10. Yes. So that's 20 here, not 10. So X equal to 20. The Y value is equal to 10. Okay, that's where the mistake is. So that should be 20. Okay, all right, so the Y value is equal to 10, 10 meter high. So we need to substitute this number in. So we've got 10 equals to -5 times by t square, 20 over v cos 36 square, plus v sine 36 times by the t, which is 20 over v cos 36. All right. Now our job is to find out what is the value of v by solving this equation. We only have one equation with one prenumeral. We should be able to solve it. Well, let's do that. 20 square, 400, times by 5, 2,000. Negative 2,000 over v square cos square 36. Plus, we can cancel these two v's, and that becomes 20 tangent 36. Because sine divided by cosine is tangent. Okay, that looks pretty good. All right, so now what we need to do is just simply move that entire thing here to the left-hand side. Okay, so we will get negative 2,000 over v square cos square 36 equals to 10 minus 20 tangent 36. All right. Okay, now I'm just going to copy this one down. V square cos square 36 is equal to 10 minus 20 tangent 36. 10 minus 20 tangent 36 degrees. Okay, I'm just going to double check, make sure I copy the right expression. All right. Looks like, yes, looks like that's correct. All right, we can do it now. All right, so now what I need to do is to find a v square, okay? How about I'm just going to do the reciprocal on the left-hand side, and so you can do the reciprocal on the right-hand side. The reason for that is just because I want the v to be on the numerator. 1 over 10 minus 20 tangent 36. All right, so therefore v square is equal to, we're going to move everything here to the right-hand side. So that becomes a division. Division becomes a multiplication, so we need to switch the order again. Okay, now if you find this is really really hard for you to do this algebra calculation, then what I suggest you is do step by steps. All right, you don't have to follow the way I did it. Okay. Okay, all right. I am not sure if this will give me the correct answer, but I'm going to try. Okay, that looks like this is the V. All right, now, of course, you can check and you can try as well. Make sure my answer is correct. But I'm just going to try if this is right. Looks a bit crazy. You've got two fractions and you've got fractions that multiply by each other. And you've got square. Oh, gosh. All right, so I got 25.9697 and goes on. So if you simplify, if you round this number, it'll be 26. What does the question ask us to find? All right, find the initial speed. Okay, and the initial speed I got here is 26. Pretty sure that's correct, but please do check with the answer and see if that's correct or not. But V, according to my answer here, is 26 meter per second. All right, so that's the 4 projectile motion questions. Now, from the previous course, projectile motion are much harder than what we are doing right now. But it looks like they sort of make the course a bit easier for the projectile motion. They only provide you 2 exercises to do the projectile motion. The next exercise will be slightly harder than this one, all right? And we'll probably, if we have opportunity, we can do some more difficult projectile motion question. But remember, at this stage, all you need to do is the 6 equation is the most important. Everything comes with these 6 equations. Once you have these 6 equations, you're basically dealing with algebra. You're substituting, you're finding the value and substitute numbers again. Yeah. Okay. All right. I hope you enjoyed the lesson. All right. Thank you.